Today we are going to talk about distributed database. So, the first question to ask would be, what is the difference between centralized and distributed databases? Centralized database, data resides in one location. Distributed database, data resides in several locations. Did not get it yet? Let's look at an example. Meet Bala. He works at a bank and all his data is stored in this one computer. What do you think will happen if his computer breaks or stops working? Yes, you guessed it right. Bala will end up losing all his data and will not be in a position to do transactions. That's when he came up with a brilliant idea. Bala decided to store his data in multiple computers so that even if one computer stops working, the others are still up and running and the data is available for making transactions. Now, let's take a look at another scenario. Let's say you're going to a bank A in location B. You decide to talk to the banker. I own an account in this bank at location C. Could you please give me some details related to my account? But sadly, the banker is unable to because he's unable to access another site due to the traffic in the network. So, what have we learned about distributed database? Data is stored in multiple locations, unlike a centralized system, whereas increasing the network traffic is not a bottleneck, and the site data is available in multiple sites. Breakdown of one site does not matter and stop work.
Distributed database architecture can be characterized in three groups: autonomy, distribution, and heterogeneity. Autonomy refers to the distribution of control of data. It indicates the degree to which individual databases can operate independently. Three alternatives: tight integration, semi-autonomous systems, total isolation. Tight integration. Single image of the entire database is available to any user who wants to share the information, which may reside in multiple databases. From the user's perspective, data is logically centralized in one database. Semi-autonomous systems. DBMSs can operate independently. Each of these DBMSs determine what parts of their own database they will make accessible to users of other DBMSs. Total isolation. Individual systems are standalone DBMSs, which know neither of the existence of the other DBMSs nor how to communicate with them. Distributions refers to the distributions of data. Of course, we are considering the physical distribution of data over multiple sites. User sees the data as one logical pool. Alternative: client/server distribution. Client/server distribution. The client-server distribution concentrates data management duties at servers while the clients focus on providing the application environment including the user interface. The communication duties are shared between the client machines and servers. Client/server databases represent the first attempt at distributing functionality. Presenting data with different modeling tools creates heterogeneity because of the inherent expressive powers and limitations of individual data models. Heterogeneity may occur in various forms in distributed systems, ranging from hardware heterogeneity and differences in networking protocols to variations in data managers. Client-server systems. This provides two-level architecture which make it easier to manage the complexity of modern databases and the complexity of distribution. Server does most of the data management work: query processing and optimization, transaction management, storage management. Client is the application and the user interface: management the data that is cached to the client, management the transaction locks. This architecture is quite common in relational systems where the communication between the clients and the server is at the level of SQL statements. Multiple client, single server. From a data management perspective, this is not much different from centralized databases since the database is stored on only one machine, the server, which also hosts the software to manage it. However, there are some differences from centralized systems in the way transactions are executed and caches are managed. Multiple client, multiple server. In this case, two alternative management strategies are possible: Either each client manages its own connection to the appropriate server, or each client knows of only its home server, which then communicates with other servers as required.